Hello. We're going to work through some examples in 5.1, 5.2 today. 5.1 is on exponential functions. So we just want to solve an exponential equation. In this example, we have 8 to the x equals 1 over 32 to the x minus 2, and we want to solve for x from this equation. And the way to do it is to try to rewrite the equation in the same base. We have two exponential functions, one on the left, one on the right, but they are this different bases. So we can try to rewrite the equation by using the same base. For example, we can rewrite 8 as 2 cubed. Okay, so that's start. Okay, so we can write 8 as 2 to the cube and 1 over 32 as 1 over 2 to the 5th. If you know that 32 is just a 2 to the 5th. All right, and then because the exponential is in the denominator, then we can rewrite it as a negative exponent. So that's using the properties of exponents. So then we can rewrite, okay, the equation as this. Okay, so we have 8 to the x, so that's what 2 to the cube to the x. Okay, because that's just the 8 inside. All right, that's already C. And then on the left hand side, we can write 2 to the negative 5 to the x minus 2, because 1 over 32 is just 2 to the negative 5, right? Okay, so let's just do that first. So that's 2 to the negative 5 to the x minus 2 on the right side. And then we can use the properties of exponents. When you take a power of exponential, you just multiply exponents. Okay, so properties of properties, I'm sorry, from exponents. And what? So let's multiply the exponents, for each side. So on the left side, we got 2 to the 3x, right? So multiply 3 with x. So that'll be equal to the right hand side will be negative 2 to negative 5 times x minus 2. So just multiply negative 5 with x minus 2 for the same reason. Oops. Now we have the same base. and these two, values on the left and on the right, they're equal. So if you have the same base, then the exponents have to be the same in order for the two numbers to equal, two exponentials to equal. So thus we can conclude that the exponent on the left hand side, which is 3x, has to be equal to the exponent on the right side, which is negative half times 6. X minus 2. Okay. We can, just solve this linear equation easily. You can distribute -5 on the left, on the right hand side. So we got -5 x plus 10. Remember, -5 times -2 is 10. Okay, and then you can move -5x to the left hand side and get positive. So we got 3x plus 5x equal to 10. So we got 5x equals 10. And that can be easily solved. And we got the answer of x equal to 2. So that's the final answer. All right. So that's one example in section 5.1. So let's do another example in 5.2. 5.2 is about logarithmic functions. So this time we're going to solve an equation for t given, this equation in here. We're going to use a different approach to solve this equation. We cannot, equate the two exponents in this equation, but we have to use logarithm to solve this equation. So the equation here is 50/1 plus 4 times e to the 0.2t equals 20. And we need to solve for t. Okay, so the solution is, the first step is to, rewrite this equation a little bit, and we don't like fractions. So why don't we just multiply the denominator on the left on both sides so that we can get rid of it. So if we multiply 1 plus 4 times e to 0.2t on both sides of the equation, then we know it will cancel the denominator on the left side, but on the right side, we're going to get another factor of 1 plus 4 times e to 0.2t. All right, then we can do different things. Now we can distribute 20 on the right hand side. Okay. So if we do that, we're going to get 50 on the left hand side. That's not changing. And then 1 times 20, that's 20 plus. Now 20 times 4 on the second term on the right. So that's 80. And e to the 0.2t doesn't change. Okay, so that's what you get. So remember, when you multiply 20 with this exponential, you just multiply the number in the front of the exponential. Okay, it doesn't go to the exponents. All right, then we can subtract 20 on both sides. and get another equation that can be solved. All right. So we got 50 minus 20 equals 80 times e to the point 2t, but 50 minus 20 just 30. So we got 30 equals 80 times e to the point 2t. All right. And then the next thing is to divide 80 on both sides of the equation. Both sides of the equation. Okay. So then 30 over 80 on the left. And on the right hand side, we just have the e to the 1/2t. Okay. And we can simplify the left hand side. Okay. So we can rewrite the left hand side as 3 over 8. If we just cancel 10. Now, we cannot rewrite the left hand side of 3 over 8 as an exponential with base e. Okay, you cannot do that. So the way to solve it is to take logarithms on both sides. Okay, take both sides. Okay, so then what happens is we get ln 3/8 equals ln e to the 0.2t, but you know, when we take a natural log, okay, ln means natural log. It means the base for the logarithm is also e, and we're trying to take the logarithm with base e of exponential with the same base. So in that case, what's given is just the exponents. So we get 0.2t. All right. When you take the logarithm of exponential with the same base, you're gonna get the exponent. Okay. So now we can solve this equation easily by, dividing by 0.2 on both sides. So divide 0.2 on both sides. So then we got ln 3/8 over 1/2 equals t. So at the end, t is just what? ln 3/8 0.2, but we can, just multiply 5 both on top and the left and at the bottom. If you do that, you can see that it just becomes 5 times ln 3/8. So we multiply 5 on the top and the bottom. So then the bottom just becomes 1. Okay, so if I write all the detailed steps, it's just 1 at the bottom and 5 times ln 3/8. We can, you know, oops. We can put 5 in the front on the top, right? So at the end, the answer is just the 5 times ln 3/8. So that's the answer. All right.